We are going to learn about different types of chemical reactions today and what are the major 5 types of reactions and how do we identify different types of chemical reactions. Let's look at the 5 types of chemical reactions first. First one is synthesis reaction, second decomposition reaction, third is single replacement or single displacement reaction, fourth is double displacement reaction, and the fifth one is a combustion reaction. Now let's dive deeper and learn about each type of chemical reactions. Let's see what happens in synthesis reaction. Synthesis reaction occurs when 2 elements combine to form a compound. Let's look at the general form of reaction. Remember that synthesis reaction is also called combination reaction. Synthesis meaning making, where making or synthesis is involved. And the other name for it is combination reaction. That's the general chemical equation. A is an element, B is another element, combining together to form a new compound. The actual reaction, formation of water, hydrogen and oxygen, 2 different elements present before the reaction. After combining, they form water molecule. Then we have carbon combines with oxygen, forming carbon dioxide. Let's look at some more examples for synthesis reaction. Formation of ammonia involves combination of nitrogen and hydrogen gas. Potassium chloride formation involves combination of potassium and chlorine. Formation of aluminum oxide involves combination of aluminum and oxygen. We are going to be learning about decomposition next. Remember, decomposition meaning breaking. Yes, you heard it right, breaking. It involves breaking of a compound into simpler form. That's the general basic equation. AB is the compound present before the reaction. When the reaction occurs, it breaks down into its simpler form, A and B. Now we're going to be looking at the decomposition actual equation where electrolysis of water when electricity is passed, then water breaks down into hydrogen and oxygen gas. Then we have mercury oxide when heated breaking down into its simpler form, mercury and oxygen. Single replacement reaction. Quite interesting to learn about this one now. Single replacement reaction is a reaction where one element replaces another element from its compound. Let's understand with the general chemical equation. A is an element, BC is a compound present before the reaction. Now, after the reaction, A combines with C, forming AC, and B is being kicked out, you see here. So this is an example of single replacement reaction. Let's look at the actual reaction. Reaction between zinc and hydrochloric acid, where on the reactant side, before the reaction occurred, zinc and hydrochloric acid is present. And after the reaction, you're going to see zinc combines with the chlorine part of hydrochloric acid, forming zinc chloride, and hydrogen is kicked out. So zinc replaces hydrogen. This is an example of single replacement reaction. To understand it better, we have to understand the activity series of metals first. Now, the activity series of metals where these metals are arranged in the order of decreasing reactivity. The metals that are placed on the top of the series, they are more reactive than the ones present at the bottom. So potassium being more reactive than sodium, sodium being more reactive than calcium, magnesium is more reactive than aluminum, so forth and so forth like that. So if you look at the position of zinc here, where is zinc located? Right here. Where is hydrogen? Below zinc. So which is more reactive? Zinc. Let's go back to the previous equation to understand. Zinc is more reactive than hydrogen. So zinc can replace hydrogen and form zinc chloride, and hydrogen gets kicked out. It's like how a strong person can kick out a weaker person. Same thing here. More reactive element kicks out a less reactive element. Moving on to the next part. The other example to look at is zinc, reaction of zinc and copper sulfate. Zinc kicks out copper from copper sulfate because zinc is more reactive than copper. So zinc combines with sulfate part, forming zinc sulfate, and copper gets replaced by zinc. The next reaction is a reaction between magnesium and copper nitrate, where magnesium replaces copper and forms a compound, magnesium nitrate, and copper is kicked out. Now let's look at the double replacement reaction. This is a reaction where exchange of ions and two ionic compounds takes place. So this is the general basic equation. AB is an ionic compound, CD is another ionic compound. So they're going to exchange their parts with each other, their ions with each other. So A combines with D, forming AD on the product side. Then we have C combining with B, forming CB on the product side. So that's how they exchange their ions with each other. These are some of the common reactions takes place during double replacement. This is a reaction between potassium iodide and lead nitrate. So if you see, they are going to exchange their ions. Potassium combines with the nitrate part, forming KNO3, which is potassium nitrate on the product side, where lead combines with iodine. Right here, lead combines with the iodine, forming PbI2, lead iodide. So they are exchanging their parts with each other, and that's what you will see on the product side. The next example is sodium sulfide combines with hydrochloric acid, forming sodium chloride and hydrogen sulfide gas. And this is a reaction where occurs where exchange of ions takes place. So sodium combines with the chlorine part of hydrochloric acid. Sodium and chlorine combines, forming sodium chloride. And then we have hydrogen combines with the sulfur part of sodium. So they are exchanging their parts with each other. And then hydrogen sulfide is formed. Now, the last one to look at is combustion reaction. Meaning of combustion is burning. And we all know that burning takes place in presence of oxygen. So what's the hint we are going to use to identify that it is looking at the reaction that it's an example of a combustion reaction? So we're going to look at the examples here. Hydrogen combines with oxygen, forming water or water vapor. So here, oxygen is one of the reactants. So the hint or the clue to look at is if one of the reactant is oxygen, that means that it is an example of a combustion reaction. All right, we are going to be practice. It's time to practice and see how much we understood, and we're going to get some mastery after practicing. All right, so you can pause the video and practice these examples. Identify, there are blank spaces provided here. Try to fill those out and see that if you were able to identify these reactions. All right, let's look at the answers now. So here are the answers. The first one, sodium combines with oxygen, forming sodium oxide. So one of the reactant is oxygen. Remember, I told you if one of the reactant is oxygen, it means it's an example of combustion reaction. The second one, where water breaks down into hydrogen and oxygen, I told you breaking is decomposition. So any compound breaking down into its simpler form, it's an decomposition reaction. So that's decomposition. Third one, SB, here SB stands for antimony. Antimony sulfide reacts with hydrochloric acid, forming antimony chloride and sulfuric acid. Hydrogen sulfide. So you're going to see here, they're going to exchange their ions with each other. All right. So their antimony combines with chloride part of hydrochloric acid, forming antimony chloride. and then sulfur combining with hydrogen, forming hydrogen sulfide here. So there are exchange of ions that are taking place in both the compounds. That's an example of double replacement. Next example. Here, it's a hydrocarbon reacting with oxygen, forming water and carbon dioxide. We do see one of the reactant as oxygen. So this is a clue for us to identify it. This is an example for combustion reaction. Next one. Chlorine combines with potassium bromide, forming bromine and potassium chloride. So what do we see here? Here, chlorine is going to replace bromine from potassium bromide. You see bromine is being replaced on the product side and forming potassium chloride. So chlorine kicks out bromine. And this reminds us of activity series of metals, right? So chlorine being more reactive kicks out bromine from potassium bromide, forming on the product side bromine and potassium chloride. Next example. So next one is an example of combination reaction. As it's quite evident here, hydrogen combining with chlorine, forming hydrochloric acid, HCl. So two elements are combining to form a compound. That is an example of combination reaction. I hope this was helpful.